Once again, welcome, my dear students. Today we discussing about the Unit 2 signal conditioning circuit and PLC system. We should be exploring the operational amplifier, signal conditioning, and programmable logic controller for industrial automation and measurement system. The operational amplifier is further classified inverting configuration and non-inverting configuration. Inverting configuration, the input signal applied to the inverting terminal through the feedback resistor. Gain is determined by the RF and Rin ratio. Similarly, inverting configuration, the base should be transferred 180 degree. Non-inverting configuration is a input applied to non-inverting terminal. Higher input impedance is the gain of 1 plus RF divided by Rin. There is no base changes in this configuration. There is an instrument, the bridges and instrumentation amplifier. Wilson bridges amplifier is to measure these small resistance changes by amplifying the bridge imbalance voltage, which is essential for strain gauge and temperature sensor applications. Instrumentation amplifier indicates these three operational amplifier configuration to provide higher input impedance and low noise and precious differential application for sensor signal conditioning. The PID controller, one of the most controlled devices, because the protection circuits. PID control is the P means proportional, I means integrated, D means differential. Protection circuit will be protect the circuit against overload and any voltage drop in the circuit. The signal processing component, there are three basic components. One is the filtering circuit, and then multiplexer, and finally the data acquisition system. Filtering circuit, it have the two types. It is active and passive filters. Remove the unwanted noise at the low level, high level, and should be give the specified band-based configuration for the signal cleaner. And then multiplexer is nothing but digital switching. It is a digital switch having one of the most multiple point inputs channel for signal output line, enabling efficient data routing techniques in the measurement system. Data acquisition system is nothing but should be store the data with the help of complete system combining the analog to digital conversion, multiplexer, and storage for real-time data collection and logging from the multiple sensor inputs. And the power semiconductor switching, we need to power semiconductor switches for the efficient operation of the automation and the electronic systems. There is a four type of power semiconductor switching. One is a thyristor, another name is called semicon control rectifier, triac, and Darling pair, as well as MOSFET. Thyristor have the 4-layer PNPN device for AC power control. Triac is a bilateral thyristor control. It will be balance the both direction as well as phase controller, enable variable power delivery to resistive and inductive load. Darling pair is combined with the two transistor configuration providing higher current gain. MOSFET and relay both is a voltage controlled switches with a fast response time. Relay provide the electrical isolation between the control and the loading circuit. PLC architecture. PLC is the program logic control system. It should be modular design enables for the flexible configuration for device, industrial automation, application with suitable and scalable input and output expansion capabilities. They have better communications, output models, and CPU model as well as input and output models for better configuration. The input-output processing is mainly used in the PLC, the input scanning and the output update. In between them, the program execution. The program execution based on the user program execute based on current input state, logic operations, timer, counters processed in the system scaling states. PLC program logic control program method is classified two types: ladder logic program and a functional block program. The functional block program is not our syllabus. We have only focus on the ladder logic programming. The ladder logic program is gives two ladder and intermediate two roots. The roots have input and as well as output. The industrial PLC application is most important because manufacturing control, process automation, safety system. The manufacturing control is used to the automated assembly lines, conveyor system, the robotic work cells require the precise sequence and safety interlocks. Process automation is to measure the temperature, pressure, and flow control in the chemical processing, water treatment, and HVAC system with real-time monitoring. Safety is the most common practice in every industry. Should be produce such a application of emergency stop, a light curtains, machine guiding with a fail-safe operation, and a diagnostic capability for industrial safety and compliance. I hope students able to understand the signal conditioning circuit as well as PLC system with industrial applications. Thank you for listening this video.